search is an important feature on document management systems. This is a topic that is quite interesting, and that's the purpose of this presentation and a code sample that we have available on the Forge GitHub website. On this talk, we are going to discuss the BIM 360 deep file search across multiple projects and accounts. My name is Augusto Gonçalves, and I'm a Forge advocate at Autodesk. And I've been working with Autodesk with many technologies over the years, and more recently with the Forge platform. So the purpose of this sample is to start by indexing the account, which means looking at all the files we have, sending that information to a database where we can search, and with that database we can search for a specific word inside the documents, inside the text and attributes on that document. That will give me a list of documents that match that criteria, and then I can point back to BIM 360. There is a live demo at bim360search.autodesk.io that you can try, but to try that sample with your account, it's best to deploy a version of that sample within your environment and using your own database. Let's start by seeing this sample in action. So I have here the live version, and I can type in a word, let's say walls, and then select the account that I want to search. That will show only the accounts that I have access, and I can click search. That will give me all the documents with that that match the criteria. As soon as I click on one of those documents, let's say this one, that will redirect me to BIM 360. So I'm not storing the actual document on my sample, I'm just keeping the database with the references and the metadata for that document, so I can search and then point back to BIM 360. Let me go back to steps and go back to the presentation. So how does it work? The first step is to prepare the database. This is essentially how we index the documents and keep it up to date. Indexing the documents is the key step of any search. This is what any search engine is doing, like Google. So Google is browsing the entire web and indexing all the documents on the web. We have to do the same thing here. To do that, we have to use the data management API to identify all the files we have on the account. We can search by file type or versions and decide how we want to get the metadata from those files. On this sample, we are focusing only on the last version of each file, and for the live version we are focusing on DWG files, but you can for sure use any other file that is supported by the Forge platform. Any file that contains metadata, of course. So DWG, RVTs are all, IPT and inventor files are all supported. Now that we know all the files that we want to extract the metadata, it's time to extract the metadata, right? We can do that with the mod derivative, and that will give us a complete list of the entire metadata for a file, which contains the attribute name and the attribute value. On this sample, we don't use this approach because that will give us a lot of data that we don't actually want. To give an example, let's say we have layer 1 or layer primary, right? We don't care about the word layer, we just care about the word, the name of the layer, 1 or primary, etc. So we're only storing the attribute value, not the attribute name on this sample. But that's a decision, and you may change the sample to use it on your own needs. Once we have the metadata, it's time to send that to Elasticsearch. Elasticsearch is a database optimized for search. And the difference is that we store documents, and those documents will be prepared in a way that it's fast to search, right? We don't want to open all the documents we have when I have an index that we can search faster. Elasticsearch is a database that you can host on your own environment, but you can also use a version that is available on demand. In this case, that is the AWS Elasticsearch that is available for that scenario. When we create a document for Elasticsearch, we don't want to keep only the metadata. We need additional information so we can link back to that document on BIM 360. So in addition to the database, we need the Hub ID. The Hub ID will be used to identify which account I can search on. So only the accounts that I have access to. The project ID, folder URN, item URN are used to link back to BIM 360. Remember that when I click on BIM on a link on my application, it opens BIM 360. To create that link, I need that information: project ID, folder URN, and item URN. The version URN is used to query the file thumbnail, and the file name is used to show that on the results. So we want to show to the user the file name that he before clicking on that file. So the version URN and file name are just for the interface. Of course, we need the metadata to search. And on the sample, we focus the search on the metadata field. We don't want to search on the other type of information. Once we have the data on Elasticsearch, we also have to keep it up to date. So we don't want to index the entire account again. We just want to update the documents that changed. For that, we use webhooks. As soon as I get a notification for a new version of a document, we run again the code to extract the metadata using model derivative and update that document on Elasticsearch. On this step, we're not creating a new document, we are just updating an existing document. Once we have everything indexed, it's time to search on the database. So when we search, we get the query from the user and send that to the Elasticsearch database. That will give us a list of results, which are the documents. And for each document, we have the fields that I mentioned, the project ID, folder URN, and item URN. With that information, we can rebuild the link that will point back to the BIM 360 product. So before we go to tips and tricks, let's see again the sample running so you can summarize that. So we click on the wall and search. Let me select account and search. Now they have the document. When I click on it, it's going to open that link with the information that I mentioned, including the item URN right here, and the folder URN and the project ID. With that, I can rebuild the link. Let me go back. As this is opening the thumbnail, to open the thumbnail, we use the access token from that user, and that will ensure that the user will only have access to the files the user can see. If I go back one step, I can see that my user is authenticated here. So everything that I do is based on my account and my account only. So only the data that I have access to. Let me switch to the sample. This is the source code available on GitHub. And the code was written with .NET Core. And if I click here, I can see all the code and the controllers for that code. And I just would like to point out the model derivative step that I mentioned. And if you scroll down the code, there is the explanation about the two approaches to extract the entire metadata and to extract only the metadata attribute values. And that's what we are using here, because that's smaller and focus only on the information we want. Now about tips and tricks on creating an application like that. There are a few things that we have to pay special attention. First is about rate limit. When we start indexing an account, it's very possible that you have thousands of files, and if we try to index all of those files at once, the API will not allow us. We have a rate limit in place, meaning that we can only call the APIs X amount of times per minute. So it's important to queue the jobs and queue the tasks and the files that we want to extract the information. That's why queuing is so important. We want to make sure that we are only extracting information for a specific number of files at any given time. And we don't want to look at the entire folder structure at once. So queuing is very important, and on this sample we use a library called Hangfire for .NET, and to make sure that we're not running over the rate limit, we have a limit on how many times you can call the API. And also there is a refresh token concern to pay attention is that when we have to update the documents, the refresh token, we need a refresh token to access that document. So it's important to keep a database with the refresh token, and once we get the callback from the webhook, we use the user ID to go back to the database, get a refresh token, and then call the Forge APIs. On this sample, to start the refresh token, we use a MongoDB database, and it's very convenient in this case because the index for the document on the MongoDB is the user ID from Autodesk. So we can quickly find the document, get the refresh token, refresh it, and gain access to the document management API, to the mod derivative API, and extract the information we want. As mentioned before, the source code is available on the Autodesk Forge GitHub. Let me switch back to that and go back to the beginning of the source code. The beginning of the repo. And if I look at the code right here, I can see that on the startup, we have the Hangfire library, and we have the management of how many files you can queue at any given time. So that's the indexing, and we are limiting to 3 folders at a time. And this is how many files we want to extract metadata. This is configurable by the environment variables. And the only challenge about this metadata indexing is that to retrieve all the metadata from a file, it consumes a lot of memory, depending on how big the file is. So we want to adjust that to how powerful is the server hosting the code. So something like 5 or 10 should be fine. But if you wanna extract the metadata really fast, you can increase that value. And one more. If I go to the search controller, that's when I search for a document and I want to show the results. And this is really fast, really simple. I'm just going to use the credentials from the user, prepare to do a search on the Elasticsearch. As soon as I get the results from Elasticsearch, from here, I'm going to send back the results to the interface. And here on the interface, we use the information to rebuild the URL. So if I show my environment variables, the network tab, I can see the search, and those are the results. Let's look at the preview. Those are the documents. I have the ID of the document, and I have the file name, folder, item, project, and the version is used to get the thumbnail and ensure that the user have access to it. As I'm not retrieving any specific information about those files, and it's using only the user permission, I know that I'm not showing additional information that is not the user should not supposed to see, and the metadata is not returned here. If you have any additional questions about how to use the sample or how to use any Forge APIs, you can use the forge.help@autodesk.com email for support. And we have Forge tutorials available at learnforge.autodesk.io, which contains the basics, which explains the basics of the Forge APIs and all the services we have in different tutorials. That's it. Thank you for watching. Hope you enjoyed this topic about how to search on files, and thank you.